All right, so you have made it to module number 14. In module number 14, we're going to do some deep work in hacking web applications. And this is actually an important module because so much of the infrastructure of the planet, well, at least this planet, maybe not other planets, but this planet is based off of web applications and web architectures. So knowing how these work and how some of the hacks function is going to be extremely important. Let's have a look at what we're going to cover in this module. First of all, we're just going to do a little summary of web application concepts, and then we're going to move into some of the threats that we're going to overview some of those threats and look at some of the most important ones. And then we're going to look at application hacking. There's a methodology that we go through, and we're going to then move into web API and webhooks. And then lastly, we're going to look at some of the techniques that we use with web application security and essentially talk about some countermeasures. But I want to give you a heads up on that too. This is going to be an overview of those countermeasures. And so what's going to happen is when you get into a project where you are testing web applications, you take this material and you share it with the dev team and with your DevSecOps team and make sure they're covering each of these points. I will talk about this when we get to that area. So let's get started with a summary of web application concepts. Learning objective number 1. Let's have a summary of web application concepts. The question is, what is a web application? And you know, we've gone through several different iterations of the web. In fact, what I'd like you to do, open up a browser tab and look up Web 3.0. Just have a look at that. If you go to DuckDuckGo and then go to images, you'll see these like these circles. Web 1.0 is small and it was just pages of HTML. Web 2.0 allowed applications to run. And then Web 3.0 helps to secure, like with the blockchain across all of the architecture. But arguably, the intermixing of large language models and generative AI may be spawning a Web 4.0. But the problem with these designations is that they're arbitrary. Someone just made them up because, hey, we're doing things differently now. Let's call it 2.0 or 3.0. So either way, when we're looking at Web 3.0 or Web 2.0, what we're doing is we're contacting a web server and we're downloading that web content. Let's have a look. So what we're doing over here is we have a user. So this is Fred. And Fred has a browser. The browser could be on his tablet. The browser could be on his laptop or some other way. And on this browser, there is a login form. And the login form has an URL. Microsoft engineers use URL a lot instead of URL. And at least they used to. And I like using URL because it's easier to understand what I'm saying. So let me grab a marker here. And if we go over to this URL, this URL, we'll see we have the .com. Oh, there's an O, right? That's C-O-M. And then after the .com, we have a slash, and then we have a question mark. And when we are running through various attacks in this module and in SQLi attacks, SQL injection in the next module, it is after this question mark going that way that we're going to have our attack. Because what we have at that point is what is called the parameter section. So what we're doing is we're passing these parameters into the back-end services of the web application. So those get sent over the internet. So the internet, as you can see, it looks like a virus there. And then we go into the firewall. Maybe it's a web application firewall. And then we go into the web server. And then the web server, we looked at some web server architectures in the previous module, and we saw that it was using these worker processes to figure out what it needs to go grab from the application server. And the application server may need to go grab information from the backend RDBMS. So relational database system, or just a database, or it could be a data lake, or many other ways that we can get that information. And as we're going to see in the next module, often this app will spawn a dynamic query. And so this is an SQL query, select star from news, where ID equals, and that's the ID that we gave it here in the parameter section. And then a table in this PostgreSQL or MySQL or whatever database in the back is going to be parsed. To parse means that it's going to, or we're going to go and ask it to give us something. And then that's going to go back through the web application server, and based upon the identity of this user, a unique page will be served up to that user. Now, what I want to emphasize, two areas for web application hacking. Number one is that information is all stored locally. That information is all stored locally. And so that's what makes it easy to hack, because when we contact the web server, again, we can modify the content and change the response. So that's stored locally. So you download the web information to your local device, and it is cached in the local device. It's run your CPU and RAM, etc., on the local device, mainly through that browser. So that's what we're talking about. So that's the number one thing. And the number two item is that the hacking normally takes place in this parameter section and through web forms. So we'll talk about that as we get a little bit deeper into this section. So that's what I want you to see. We're going to look at everything like SQLi in the next module, cross-site scripting. We're talking about session hijacking before. You can do that with hacking web applications. You can attack the backend SQL server. You can attack the web server. You can attack this entire architecture. So that's what we're going to be doing in this module. Okay, so we are now in learning objective number 2. And in this case, we're going to be demonstrating web application threats. So let's have a look. So for web application threats, this is the risks from OWASP for web applications taken for 2021. So if you're taking this class and it's 2025 or 2026, it's possible that it might be updated. If it is, guess what? I bet you it's substantially the same, because they just kind of moved some things around from the previous one and maybe added a couple of more. And so an overview of this is going to be broken access control. Remember, we already talked about directory traversal, cryptographic failures, injection, insecure design, right? You'll want to make sure that we have appropriate design. We're going to talk about some of the mitigations when we get to the back end of this module. Security misconfiguration that might allow a cross-site scripting or something like that. Vulnerable, outdated components, identification, authentication failure, software and data integrity failure, so that maybe somebody's able to capture. We're going to see insecure deserialization a little bit later. And if somebody's able to tap into that, they can do a lot of damage. Also, we have security logging and monitoring. We're talking about it takes a long time for an organization to realize that they've been hacked, and just because they're not monitoring. And then last is server-side request forgery. So these are the top 10 risks. But check this out. 35 web application attacks. So wow, 35 of them that we're going to go over. So that it starts over here with directory traversal and moves through a variety of different attacks. And we're going to look at these. Some of these will land and spend a little bit of time. Others we will just sort of overview it. And at the end, we'll see that, oh my goodness, there are a lot of web application attacks. Let's start with directory traversal. We already talked about this, so I will not belabor the point. But what we're trying to do is get to another location, the web server, where we can conduct an attack. So we have this //// and notice it takes place right after that question mark, right? Some directory, some file, and I can use that. We're going to see this in a couple of different ways as we go forward. But remember that for the exam, that pattern is directory traversal. Another one is a hidden field manipulation attack. This is an attack that has happened a lot in the past. And what you do with hidden field manipulation is use a tool like a Burp Suite or something like that so that you can reveal the hidden fields. And in this case, the hidden field has the pricing information. And then as you can see, we're after the question mark here. So what we're going to do is modify the price from $2,000 to $2. So maybe you're buying a big appliance or something like that. And then you hit enter, and it takes you to the to purchase, the purchase box, and you pay $2 with your card, and next thing you know, they ship you a washer and dryer or something like that, right? So that has happened before, even to big companies like Amazon, but far in the past. All right, another one would be a pass the cookie. Now, obviously, passing the cookie is something that we want to do after lunch, though, right? You want to have your dessert after you eat. But either way, what this is not a cookie like that, but the cookie that helps track session information on your local device. And so in this case, you have that session cookie. It's going to be generated when you go to the web app. And but we have an attacker, right? The attacker is going to do what the Cookie Monster in Sesame Street does: steal the cookie, and then use that to create another session. So if my cookie has all my session information and it's not defended well, then I can take that user and impersonate them on another site or something like that. All right. Also, we have the idea of a same site attack. Let's talk about that a little bit more. With the same site attack, I want to bring to your memory, if you go way back in the past, and what we were doing is we were in module 2 or 3, one of those two modules, and we were using tools to find subdomains, a sublister and other tools like that. And when we were using those tools to find those subdomains, I was talking about a subdomain that Microsoft had for a long time that was not secure. And I also mentioned that quite a lot of very, very large companies can run into an issue where they lose track of the security on their subdomains. And I've been in organizations where subdomains are kind of created. Somebody says, hey, we need to do this right now, and somebody creates a subdomain, and then later on they're like, oh, we're not doing that project anymore, and then maybe the subdomain is forgotten. So that is why they can be vulnerable, and there are a myriad other reasons they can be vulnerable. But let's have a look here and talk about the same site attack. So the mechanism that we're using here is this user's browser, and they're going to initiate a request for a perfectly legit web application or website. But there's this attacker. You can tell, look at that red skull. Anybody with that on their laptop has to be evil. Now, this attacker, what he's going to do is hijack a subdomain of a legitimate website. And so this is going to involve a little bit of a DNS. And so in terms of DNS name resolution, the resolver that's going to help take this user's browser and send them to the appropriate website is going to mistakenly redirect them to the hijacked subdomain. So this is, if you look at this domain, it's certifiedhacker.com. Look at that. This is also certifiedhacker.com, so the root domain is just fine. But now there is this RANS domain that is the attacker, one that the attacker has targeted. And it can result in data theft and many other things. So the targeted domains are going to be like your familiar TLDs, like .edu and .net and .gov and so on, .com, of course. And what they're going to do is exploit the fact that the domain, the second level domain that the organization has purchased, and then they created subdomains for that second level domain, is misconfigured. And so what we're going to do is make use of a tool called TLDs. So those are top level domains. So TLDs, top level domains. So you create a dangling record. You see that RANDS right there. It's a subdomain that points to a non-existing resource. This is actually used to extend TLDs, and we use that as part of our attack. So what we have in the process is the user gets redirected, and they're supposed to be going to www, but instead they go to RANDS and they get hacked. So that's what we're talking about with the same site attack. So I guess what we're saying is if you work for an organization, especially a large organization, you need to go through and check every subdomain that you have and every full path on every FQDN that represents your organization. All right, the next one we want to look at then is command injection attacks. And there are various types of command injections. What we're doing is we're crafting an input string. In this case, we're doing a shell injection. What is a shell? A shell is like a terminal window that allows us to control the operating system. And so what we're going to do is use functions like system and start process and many others, API commands. We're going to see a little bit more of this a little bit later. We also have HTML embedding, and this can allow you to embed HTML so that when somebody visits the web app, it's defaced, or you can put in arbitrary code or scripting. Files also. So if you see the certifiedhacker.com FQDN right here, we have a the page here, which is vulnerable.php. And then right here where it says question mark, right? So it's supposed to be a color, but instead of a color, what we do is we put in a path to an exploit. That file is injected into that path. So many different possible injections for command injection. I have some examples of these. So I'm going to go over here so we can zoom in on this and have a look at some of these examples of shell injection. So we see this Python code. And what we're doing here is we have a vulnerable code. We have an input file name and the os.system. We have this fcat user input. And what's going to happen is the attacker is going to enter the file name, but they're going to use an rm-rf/, which this command is going to be executed on the server. And that's going to really hit that system hard and damage the system. We have another code example over here for HTML embedding. And so in this case, this is JavaScript code that gets inserted, embedded to a web page. And so in this case, what we have for our code is we have a post method, and we have some type of comment that's going to be input. And if the user input into this isn't sanitized, an attacker could submit into this something like script alert, right? Or script, whatever arbitrary script we want to use. And the last one is file injection. And so what happens is, in this case, we have a PHP, and we have a color that's supposed to be submitted into this code. The attacker is going to submit a bash copy code instead and allow them to run PHP on the back end of that server. So these are just some code examples I put together to illustrate some of these points. All right, we also have another type of attack, which is LDAP injection. So with LDAP injection, what we're doing is we're taking LDAP, the Lightweight Directory Access Protocol, and this is something that if you, in the back end is used for things like Active Directory. And what we can do is we can, instead of putting the input into the form that it is expecting, we put an LDAP path. And this is just an example of an LDAP path where we have server.example.com / that canonical name, users, and the domain component, which is example, and another domain component.com. So user.example.com. Then we look over here and we have another example where we have an organizational unit. This is the engineering organizational unit, which is underneath the department organizational unit, which has a domain component of example and com. And so we have ways of doing LDAP paths and inserting and finding information about it, etc. The next one we talk about then is cross-site scripting. You'll hear this quite a lot in topically, an overview of cross-site scripting. What happens when the user goes to a page, so like maybe clicks on a link and then the page loads, that's when cross-site scripting occurs. What's going to happen is they're going to get a pop-up, very likely, that they're going to need to interact with. So I bring this up because you don't have to click on anything to initiate it. Well, actually, you do have to click on the OK or whatever it is, but you don't have to log in. That's what I meant to say. You don't have to log in, and we'll talk about the differences between cross-site scripting and other attacks in just a little while. So what's going to happen here is this attacker here is going to find a web server that you see right over here that's vulnerable and insert arbitrary code into that web server, and then use some type of methodology to attract the user to that web server. So for instance, let's say I find a web server that has 10,000, let's just say 1,000 pages, not 10,000, that's a little bit big. And on one of the locations in that web server, I find an XSS vulnerability, and then I load my code into that location. The problem is what if that location is never ever used? So what I do now is I take that location, put it into a URL as a link, and I send it in a text or send it in an email, and that's how I get them to click on it and use it. But we're not only doing cross-site scripting on some hidden page somewhere. It could actually be a comment field, so that you're in somewhere where it says to leave your comment, and instead of leaving a comment, you fire up your script tags and run arbitrary code, or it could be a blog post or whatever. And when this thing pops up, when the user interacts with it is when that code actually gets to run on that system. So there are techniques that are used to evade filters. So for instance, I have a web application filter, and I don't want people using cross-site scripting techniques to attack my web server. So I look for things like script tags and other HTML elements or PHP elements that might indicate someone's doing cross-site scripting. So what I can do, and they're going to see this over and over again in the next two modules, is I can encode the characters. So these characters have HTML, right? And so I can crank it over into ASCII instead of HTML, or I can add white spaces. So I do, instead of JavaScript, Java space script, and it's got spaces in it, so the filter is looking for something that says JavaScript, but this says Java space script, and so it does not match the filter. So boom, you get in. Or you can manipulate the tags so you break it up so it doesn't look like a script tag to the filter, and maybe you can evade the filter from there. Another type of attack is a timing attack. And so what we're trying to do in this case is retrieve information through what's called a side channel attack. We're going to mention this several times throughout the rest of the course. So I want to talk a little bit about what a side channel attack is. Let me grab my marker here. So what a side channel attack is when we're not actually attacking the resource itself, but we are analyzing the resource environment. So let's say that there is this box over here, and this box has we'll draw a nice big CPU so I can put the letter C in it. It has a CPU, and it's communicating with some resource somewhere. And there are messages that are being sent into and processed on this box. And those messages are encrypted. But I am not sure exactly what encryption is being used. And if I can figure out what encryption is being used, then I can begin some other type of side channel attack to attack that encryption. So maybe I can tell what kind of messages are being sent, etc. So fortunately for me, this box is sitting on a shelf that I have access to, but I have no access to the box inside, the interfaces, the software, anything. So how do I determine what encryption is being run? Well, what I can do is I can use some type of detector that looks for heat coming out of this processor, heat blooms. And then I have a little transducer that I have on the system that looks for vibration. So maybe when CPU fans come on or something like that. And so I take that and I characterize the heat blooms of the processor. Maybe I even have a transducer on this, not a transducer, but a way to snoop on the electromagnetic signature of this line. And all that put together, I can characterize what's happening. So I find out that they're using a CAST 128 encryption. If I characterize how the CPU works whenever a message goes through, and every Thursday morning, they have a bulk traffic decryption fest. Here, how do I know? Well, because that's the only time when the CPU fans really go fast. So I know a little bit about it. Do I see the message? No. Do I have access to the encryption? No. I just have signature files for how systems behave when they're doing this type of encryption. So it's a side channel attack, and it's not a direct attack. We're going to see this many times coming up. And so in this case, we're not looking at the page. We're looking at the timing. How long does it take? We're not looking at the code. What we're doing is we're looking at if I send my own code in and it comes back, what's the timing that it takes? I'm not looking at the actual web app itself, but what I'm trying to do is, again, look at the time it takes for processes to get processed. And then what I can do from there is begin to characterize what technologies are in play. And if I can correctly characterize those technologies, then I can begin to fish for attacks for those technologies. All right, so now let's look at an XXE. An XXE is an XML external entities. So what's going on in this case is this attacker is putting together a malicious request. What's the purpose of this request? To parse XML input. So I'm sending that in, and you know what kind of response I get back? It's a TMI response, too much information. I should not be able to get a response back that tells me that this is running on a specific version of Ubuntu. Once I find out that it's running on a specific version of Ubuntu, then I can attack that version of Ubuntu. Another one is unvalidated redirects and forward. So I have an app and somebody clicks on a link on the app and it forwards them somewhere else. And sometimes it'll even redirect them outside of the site. And these are not validated. So the attacker can have an email, for instance, that contains a rewrite link, and then they can get redirected, forwarded to a different server. Another type of attack, there are a couple of these. One is called a mage cart attack, and the other is called a watering hole attack. So with a mage cart, the attacker is going to insert malicious code into a vulnerable e-commerce website in order to gain information about it. So in this case, we're using a cart, a shopping cart, e-commerce. And in the watering hole attack, have you ever watched a nature program? So you're watching a nature program and they're showing the plains of the Serengeti. There are these like heat waves going up. It's hot. And the announcer will say, "It is a dry season in the Serengeti, and the animals are thirsty." And then he will go on to describe how it is that there's only one watering hole, and waiting at the watering hole is like a pride of lions. And then backed off, 50 meters is, some Robux or something. They want to get the water. They're thirsty. They're dying. And when the first two go in, they get attacked by the lions. Once the lions are satisfied, then all the rest of the animals go and drink out of that watering hole. So what's that all about? What does it have to do with web application attacks? Well, here's what it has to do with it. So what happens is you have a organization. Let's say it's an aircraft engine engineering organization. So what do? They do engineering stuff. They do finite element models. They use CPU compute. They frequent the FAA and other licensing organizations. So you look and they have a set of sites that they visit all the time. That is their watering hole. They go there all the time. So if I'm an attacker, what I can do is look at those most visited sites. Let's say take the top 500 or something like that and find the ones that might have some type of vulnerability, and then take advantage of that vulnerability and lie in wait for the attacker, for the victim, for one of the people of that organization to visit the site that I've corrupted or the attacker has corrupted. And that's called a watering hole attack. So remember the plains of the Serengeti. All right, so the next one we're going to look at is a cross-site request forgery. So let's have a closer look at the cross-site request forgery, because often what I'll do is I'll get a question as to what's the difference between the two. First of all, let's do a little overview of the CSRF versus the XSS. So if you look over here, cross-site request forgery, it's another web exploit. And we're looking at vulnerabilities on the web server. So far, it's the exact same thing as a cross-site scripting attack. And the attacker can now force an unsuspecting user's browser to send malicious requests they did not intend. But how does that work? There is a crucial difference between the way this works. And that is number one right here. So whenever you see CSRF, remember we're talking about the fact that the user logs in. They log in. And that login is then used against them later on. So let's talk about this. So with cross-site scripting, the attacker is going to inject malicious scripts into a vulnerable web server, a vulnerable web app. With cross-site scripting, you can do things like steal cookies, run arbitrary code, or whatever. With cross-site request forgery, we're tricking the user into making an unwanted request to a website they trusted, where the user is authenticated. They logged in. And the request is going to be done through hidden forms, image tags, or other ways that the user doesn't even notice. And the attacker is going to leverage their existing session. So those are some of the differences in terms of the attack vector. But what about the target of the attack? So if this were a cross-site scripting attack, the target is other users of that web application, other users of that website. And sometimes crafted messages with links will be sent to users to get them to click on and take advantage of cross-site scripting. We want to execute code when we're doing cross-site scripting. But if we look at this CSRF, the target is a trusted web application. And so the attacker forces the user's browser to send in a request somewhere where they trust after they logged in. So it's a different target also. Also, if we look at cross-site scripting compared to CSRF, in terms of the dependency on the user, cross-site scripting, the user is going to interact with a malicious script. The user sometimes can be arbitrary. They're going to need to click a link, right? They're going to click a link on some arbitrary page. Whereas with CSRF, we're not going to necessarily click a link. You know what we're going to do? Log in. So the user logs in, and the attack exploits that unauthenticated session with the trusted site. So the purpose of the two of them are a little bit different too. The purpose of cross-site scripting is to execute malicious code, whereas the purpose of cross-site request forgery is to do unauthorized actions. In other words, I'm forging an action with that user credential that they wouldn't normally do. And so they are both a little bit different. But if I were to sum it up for the exam, it is this. Let's have a look over here. Like I mentioned in the first place, logs into. That is for the exam. What do I mean by that? Here's an exam question for you. An attacker found a vulnerable web server in order to, take advantage of the users at CEH Corp. The user, Fred, logged in. Oh, wait a minute. What did you say? Logged in to a trusted site using his credentials. And the attacker was able to use the stolen information to do something in that user's name or whatever. But the keyword would be logged in, right? So now you get a choice of answers on the exam. Answer A, it was a cross-site scripting attack. No, right? The user doesn't need to log in for a cross-site scripting attack. Answer B, it was a marionette attack. No, it wasn't a marionette attack. Answer C, it was a rocket attack. No, we don't do rocket attacks for the CEH, all right? It was a CSRF. So that keyword logs into, very important. Cookie poisoning. What is cookie poisoning? It's when somebody takes your chocolate chip cookies and puts raisins in them. What are you doing? Actually, I like raisin chocolate chip. Those put nuts in it too. But these types of cookies are used to help maintain user states. And so what can happen is you can use a tool like Burp Suite or other tools to go grab that cookie, modify the contents, put in malicious content, even take the session data that you find in the cookie that you see right here, a couple of different cookie examples, and steal the session. You can do quite a lot with cookie poisoning. Very interesting stuff. So the next one we have is insecure deserialization. Do you know what deserialization is? You go into the kitchen for breakfast and the box of cereal is empty. Someone deserialized it. I can't believe when they do that. Well, now I have to go back to the store. But what this really is let's say there's a web form and it has something for me to fill in, name, age, whatever. In order for that information to get across the wire, it has to be put into a format. It's actually a much lower level format than this, but this is a good representation to be sent to the web server or wherever it's going at the back end. And it is not protected, so an attacker can inject something into it and like create a different account or change a password or something like that. The next thing we look at is a web service attack. Oh man, so with organizations that do Web 3.0, we have a huge amount of web services. So we have WSDL, the Web Services Definition Language. We have UDI. This is going to be your Universal Description, Discovery, and Integration. We also have SOAP, which is, SOAP has been on the way out for a couple of decades. Like, we're not going to use SOAP anymore. Oh, let's use SOAP in this app. But anyway, that is your Simple Object Access Protocol. And these are various tools that are in a web services stack, from the presentation to the security, to the discovery, to the access layer, to the transport layer. And if, for those of you who are on dev teams, you write programs and apps, a lot of this will be familiar. But if not, what we need to look at just in general are what we have here to the right of this stack. And that is the following. When we look at the presentation layer and security layer, it's vulnerable potentially to parameter tampering, WSDL probing, SQL XPath, and other types of command injection, malware injection, brute forcing, etc. If you go down here to the discovery layer of where the UDI and WSDL, code leaks, permission access attacks. If you go down here to the access layer, SOAP and REST, XML parsing. Why? Well, because especially for SOAP, it's represented in XML. Spoiling schema, complex or recursive payloads. This is kind of like a DOS or a DDoS attack, and large payload, same thing. And then sniffing and snooping, WS routing, replay attacks, and denial of service attacks can happen here at the transport layer, because we have HTTP and HTTPS and many other services. So these are the web services that make web apps run in the back end. So what we want to do with these web services is find out what web services are running. We're going to use a web service footprinting attack. So what we do is we craft an XML query. All right, so for those of you in this class who are not really dev, like I would say about 50% of my students don't do a lot of programming. So how would I know what type of XML query to make in order to elicit a response through a footprinting attack? Well, there are a couple of ways you can do this. Number one, you can go online and look for web services footprinting, and you can find examples of these online, and you can just modify them for what you want. Or, like we'll see a little bit later, you can use a large language model, or you can use AI to help you put together the XML query. But for those of you who are just that good, you can do this yourself. So what happens is we send this query in, and it elicits a response. And the response contains within it TMI, too much information. Look, I have the web server version, and I have the technology it's using, and I can get other information. This helps me to footprint, find out information about these web services. And then we have poisoning. This is XML poisoning. So in this case, we put together a poisoned request. And so we have, over here, we have a customer number, first name, last name. And then at the end, what we have is we send it in, and we can do all kinds of stuff. We can cause it to give us information back, create a new account, create a new password, so we can do XML poisoning. The next thing we have is a DNS rebinding attack, and I think we've seen this in various ways throughout the rest of the class. Won't spend too much time on this, but what we're doing is we are making that user make use of the attacker's DNS services. We'll talk just a little bit about the same origin policy and a little bit later in CORS and how that works with that. But anyway, what we want to do is allow the attacker to make arbitrary requests, redirect the browser, etc. That's DNS rebinding. And then we have clickjacking. So with clickjacking, I want to highlight some terminology that might be important for you if you're doing a practice test or something like that. So let me give it to you from the user's vantage point, and then we'll talk about some of the terminology. So here's a user. They click on a link in a browser, and something weird happens. Something weird happens because over here, the victim's browser opens a website somewhere else. What happened? And how come the user didn't know that it happened? Well, what happened is there is a UI, right, that the user is making use of, the user interface. And this is called a UI redress attack, where we're messing up the UI. So there are vulnerabilities that we find in HTML, and the key term here is HTML iframes. And the location where a lot of this takes place, the configuration location, is in the X frame options header. And so what happens with this user is they don't know it, but there's something kind of floating in front of their mouse pointer. And they don't know it, and when they click on it, it clicks on that. And it's invisible. So, and not the underlying web page. And that's what happens. See that overlays a malicious page element that above their little mouse arrow, they click on that, and it clicks on that page element, and then they're attacked from there. All right, another one is a marionette attack. What's a marionette? Have you ever seen, you have like a these little wooden things with strings, and you can make a little doll dance. That's a marionette, but in this case, we're not making a doll dance, we're making a browser dance. So a lot of attacks that would be on an operating system can potentially be in the browser. Now, I need to do a little research because I've never seen this in the field yet. Where we get this information from is research into browser vulnerabilities, and there are several teams that were able to demonstrate the marionette attack. So this is inside the browser. What we're looking specifically at is Server Worker API, the Server Worker API through the website. That the website can be controlled by the attacker. And so they browse to the website, and Service Worker automatically activates, and then you can run those service workers. We're talking about that in the architecture a little bit earlier in the background. So now what happens with this is essentially now the browser of the user is acting as the processor environment. And so now, rather than running a cryptojacking attack on the operating system, I run it on the browser. Now, rather than making the operating system part of a botnet, I make the browser part of a botnet. And so I make the browser dance to my tune. This is the marionette attack. Okay, the keywords for this, for the exam, is a Service Worker API. That's what we are focusing on. And it allows that browser, it's a browser attack, to become part of a botnet or do cryptojacking, stuff like that. Okay, now we are in learning objective number 3. And here in learning objective number 3, we're going to look at the methodology that we use to hack web applications. Let's check it out. All right, so here we have 13 different areas that we're going to look at. Footprinting, analyzing, bypassing, client-side controls, attacking authorization, attacking access controls, all the way down to, we were just talking about web services. We're going to look at that also. So let's start with the first one. All right, so the first thing we want to do is find services. We already talked about this in module number 2, using Netcraft and Whois and so on to find out, characterize the web app and characterize DNS with DNS Recon and DNS Dossier, and then banner grab with Telnet and Netcat and IDserve and Netcraft. So we're putting together the picture of what this is. And then what we want to do is go find services and ports. Nmap -lowercase s uppercase v. We're going to use tools like NetScan Tools Pro, and we're going to use Open Port Scanner from SolarWinds. So we're going to further look a little bit deeper and find the services and ports. Next thing we want to do is find out what we need to get around in order to get to the web app content. The first thing we need to get around is proxies. So we want to find out if proxies, we can use the HTTP1 trace method to identify proxies. And then we can use tools like WAFWoof to look at web application firewalls. And so we find out, hey, are there proxies? Are there firewalls? Again, we go into Obsidian or whatever, and we make note, keep track of what's going on. And so that we can, if there are no proxies and no web application firewalls, that's very nice, but usually you're not going to find that. If you want to engage a large language model, a little bit of AI in order to help out, you can do it like this. Check if the target URL, certifiedhacker.com, has a web application firewall. We didn't tell it what tool to use. And so what it'll do is it will choose the tool it wants. In this case, it chose Nmap. Check if the URL is protected with a web application firewall using WAFWoof. And so in this case, we told it what tool to use. And so our little AI friend helped us out with that. Another thing we want to find is there any hidden content? And usually there's a lot on a good web app. And you can use Burp Suite. I've been talking about that quite a lot. But The Zed attack proxy is actually very, very good for this. It can do spidering. We can go find content. We can find information on the site. We can look at the cookies. We can look at everything, finding that hidden content. Next thing you want to do is look for load balancers. So just like proxies and web application firewalls, if the site is spread across multiple load balancers, that can also affect the way we hack it. So we can use Dig. Dig is the DNS tool from Linux to expose web balancers. We can also use a little app called LBD to expose load balancers and see how many load balancers that there actually are on this site and where they are, and that can help figure into our attack methodology. Let's do it with AI. So use load balancing detector on a target domain. So we tell it to use LBD. There it is. So it shows you all the load balancing information. And now that we have that information, it helps us to further characterize the environment in which that web app exists. Also, we want to find web technologies, a couple of tools. This is a nice little plugin that you can put in Chromium-based browsers like Google Chrome or Microsoft's. There are many browsers that are Chrome-based these days, but you can plug that in. And so what we want to do is identify the technology, and all you have to do is visit the site, and boom, it pops up and shows you. And then you also can use built with in order to find the technology. So we find the underlying technology, and then we go from there. Another one is WebSockets enumeration. So let's have a look at that from over here, and we're going to talk a little bit about WebSockets. All right, so what are WebSockets? WebSockets are a protocol that's going to give you full duplex communication channels over a single TCP connection. So if you were to use traditional HTTP, you wouldn't be able to do that. So WebSockets is very good for that real-time communication. So it's very good stuff. So single TCP connection, low latency, it's very lightweight. And so let's have a look then at STUs. So over here we see that STUs, it's going to allow the attacker to discover WebSocket endpoints. And STUs is the security testing and enumeration of WebSockets. Hey, there's the nice W in STUs. This tool is going to help you determine what's going on. So if you look down here at the very bottom, what we're going to do is bash. We're going to use STUs fingerprint.py, and we're going to give it some parameters here, and we can use this command to do WebSocket enumeration. And why do we care about WebSockets? Well, they're important in conducting and preventing denial of service, man in the middle, injection attacks of various types. And if you want to avoid people using tools like STUs to enumerate WebSockets, and you probably should use TLS, encrypt your connections, validate your inputs, things like that. So STUs is a very interesting tool for enumerating WebSockets. Another thing that we're going to want to do is analyze the application itself, maybe get an overview of the application. And we have talked about Burp Suite quite a lot. ZaProxy is another one, and a huge set of tools are very good for getting us information about the OS and the software, subdirectories, and the technologies put together, and so on. So Burp Suite is really cool. We're going to use that fairly extensively in the upcoming labs. The next thing we want to do is maybe just take the entire app, the entire website, and mirror it on our own local system. And then that way we can sift through the HTML, maybe pop sections of the HTML into an LLM and have it examine it and see if there are any issues with it. Or maybe use our another type of parser to pull more information out of the HTML that we download. So if you want to mirror the website with an LLM, large language model, your AI, this one we do mirror target website certifiedhacker.com. So we don't tell it how to do it, we just tell it to do it. Another one is mirror that website with HTTrack. And so in this case, it'll open up HTTrack and mirror the site. So it uses the tool for you. And by the way, this can take a little bit of time. And it is either, there are 3 factors in mirroring the site. What content is available. Let's say 4 factors. What content is available. The speed of your connection to the internet. The speed of the connection to the hosted web server. And then the speed or the busyness of the web server. So often at some point you'll want to set limits, and you could do that with HTTrack, and so that you're not just downloading the web application forever. All right, so also we want to find entry points for input. So what we're going to do in this case is examine some of the components and elements of the web server. The URL, the HTTP header, the query string parameters, the post data, the cookies. Find input fields. That makes a lot of sense because that's where we do a lot of our attacking. Identify parameters that can be processed. Remember, we're talking about the user agent. That's one of them we can attack. Refer, accept language, host headers. Also determine the encoding technique. We've already been talking about encoding. We'll talk a little bit more about that as we get deeper, but some of the same tools that we've been talking about down here are the ones that are used for these types of operations. And then we want to look at the server side technologies, do detailed fingerprinting, look at URLs, get session information, examine tokens, look at IISP.net, use WhatWeb to determine what's going on. And then, of course, with HTTPrint, we can even pull out more information, fingerprinting that web app and that website and get those technologies. So we're trying to find out what's in the back end, what's going on with that server, and we can do that with some of these tools. And, hey, we can do it with AI. So let's have a look here and seeing what we're doing with our SGPT command this time. So we're going to launch WhatWeb on the target website to perform website footprinting. We're going to run a verbose scan and print the output and save the results in WhatWeb text. So we set it, forget it. It runs and outputs it, and then later on we can cat that text file and see what's in it. So very cool stuff. Another thing that we want to do to characterize this website is find files and directories. And we were talking about that a little bit earlier, looking at things like GoBuster, Dirbuster, Derby, and Nmap, HTTP-enum to enumerate applications, get those files and directories. We can run ChatGPT, talk to our AI, and in this case, we're doing a scan the web content of the URL www.moviescope.com using what? Hey, that's one I mentioned before, Derby. On this one, we're using GoBuster. So GoBuster is what that one is called. All right, so now we just look for vulnerabilities, and there are some very nice vulnerability scanners out there like Vega and WP Scan. Oh, by the way, this one here, WP Scan, very nice tool to go grab information from WordPress sites and do a lot of hacking at the WordPress level. It's very good stuff. And then AppSpider and Uniscan. So lots of tools out there for doing this. And then, of course, we can bring in good old AI, perform vulnerability scan on the target, perform vulnerability scan using Nmap, perform vulnerability scan and save, that's using Sniper, save the results to file. So we're in the lab. When we get into Burp Suite, you'll see there's a variety of attacks that you can use against web applications. And one of them is Sniper, and we'll be using other attacks from Burp Suite when we get into the lab. The next thing we want to do to attack this web application, there's a problem here. There's a problem. Somebody is blocking me from getting to those delicious resources that I want to get to. So we need to bypass those client controls through cross-site scripting, request forgeries, parameter tampering, etc. Let's start with attacking browser extensions. This is at the client side. So what is the deal with the browser extensions? Well, it is very app-like. And just like we saw in Module 7, where we could decompose an application, we can do that here too. So we can decompile it, decompose it. We can analyze the traffic going to and from it with Burp Suite. So we can characterize it and then maybe hack it. Another one we want to do is attack the authentication mechanism. Maybe there is a username that's required. And so what we could do is enumerate that username. Maybe look for failure messages. This is one thing that you're going to see come up a lot later on in this module, and a huge amount in the SQL injection module, is that having failure codes is great. If I have an error code or whatever, I can use that to help characterize the web app even more. Predictable usernames. Hey, maybe that's the case and I can find the username because it's predictable. Or maybe getting those cookies and replaying them, or hacking them, or cracking the passwords, running a dictionary attack, or using session token prediction, or brute forcing that small session token, or maybe bypassing SAML-based SSO. So for authentication, we'll be taking a kind of a closer look at SAML and how it works for a single sign-on, but we'll do that in just a little while. Maybe there's a rate limit we can bypass, or bypass MFA, many ways of doing that. Another thing we want to do is look for design flaws. Maybe bad passwords, we can brute force the login, we could look for verbose failure messages. So if you look at each one of these, there's quite a lot that we can do in terms of authentication mechanisms. One of the authentication bypasses, it's not quite a bypass, but it's a way to get past it. Let's say, going back to one of our previous modules, that I go to LinkedIn and I download a bunch of employee names, and then I go to the employee website and I try the employee name. It says username does not exist. Try another one. It doesn't exist. Try the first name, first initial, underscore last name. It doesn't exist. Try first name dot last name, and it says, I'm sorry, but your password is incorrect. All right, I got a username. Very nice. Now, not every WordPress site or whatever will allow you to do 200 tries on a username, but you can get some of them that will let you iterate through for a while. And then we have password functionality exploits. There are various ways to look at the password changing. So we can spider and find, like for instance, a place to put in a password, old password, new password, confirmed password. We're looking for those fields. Once we find those fields by spidering the application, then we can attack the password change methodology. Another one too is when you download the web app, go through the HTML. Sometimes you'll find passwords in the HTML itself. And then there are password recovery techniques, like when you forget your password. One of the things that used to happen, which doesn't happen hardly anymore, is, at least not in this method, but celebrities and politicians used to get attacked. How did they get attacked? Well, what would happen is somebody would go to the Gmail account or Outlook account or whatever it is of the celebrity or politician, and then they would hit the forgot password button, and it would take them to a recovery page, and it would say, what's your mother's maiden name? So you just, let's go to Wikipedia of this movie star. Oh, I see, her mother's maiden name was, and then you put that in. What street did you go on? You look on Wikipedia. Oh, there's no street here. Let's go to IMDb. Yeah. And you go to IMDb. Oh, it's not there either. And then you go to a paper that was written on her origin story. Okay, good. We found the street. It's 123 Main Street. So you put that 123 Main. Oh, that works. All right. And then it asks another question. So you just go look it up, and then you open the email, change the password, and then dox it. That happens it used to happen even more using that technique. But these days with MFA and 2FA and other ways to secure these accounts, it doesn't happen quite as much. All right, so let's look at some more attacks against the web app. In this case, this is exactly what we're going to do in the lab. And this is brute forcing the password, So I want to explain something while we're here. We'll talk about this when we get to the lab also, and it'll make a lot of sense. Let me just go grab some red here. All right, so what we're going to look at then is Burp Suite in dark mode, which I really like. And what we're looking at is the web information for the login page for an app. And there are multiple fields that you will be able to capture in Burp Suite. But what we're going to do in the lab, and what you could learn to do yourself by doing it, is capturing the username and password field. And then once you capture the username and password field, what you're going to do next is several things, and I'm not putting them in order, but you're going to choose a type of attack. You're going to choose a dictionary for the username and a dictionary for the password. And once you choose all those things, then you'll click on Start Attack, and it'll go through and try the entire dictionary against the web app, right? So that is brute forcing. That is a dictionary attack. And you'll see this in the upcoming lab. So yeah, that's actually a pretty cool tool. I like Burp Suite for that. And then another thing you can do is attack the password reset mechanism. Let's have a look at some of the methodology for this. So if you look at this slide, you'll see that we have 4 different steps that we use to attack the password reset mechanism. And this is called a password reset poisoning attack that we use to hijack the password reset mechanism, the website, and then gain access to the target victim's attack. And so the way it works, the first thing we're going to need is we're going to need their email address. And we get that information. There are many different ways to do that. And we could do social engineering or OSINT if we want. There are many different ways to get that email address. The next thing that we're going to do is put together one of the core parts of the attack. And so this is going to be a password reset request. We're going to send that in to the target website. But on the way in, we're going to have modified the host header in the HTTP request. And so what we see here is we have the HTTPS certifiedhacker.com reset PHP with HTTP 111 accept content type. So what we're doing here is the manipulation is that we're changing the host header from the legitimate domain certifiedhacker.com to our own domain, which is right here where it says host, badhost.com. So what's going to happen now is the reset link that's going to be generated by the website is going to include the attacker's domain, badhost, and with that reset string that we see down there. So what's going to happen is a link down here is going to be sent to the email of the user that we're targeting. And it's from a legitimate website. If you put it together, it looks totally legit. And but the reset link points to the attacker's site. And so what's going to happen then is the victim of the attack thinks that the email is legit, and they're going to click on the link. It's a malicious link. And when they click on the link, they're going to be directed to the attacker's site. And then the attacker can use the token to reset their password on the legitimate site. And then they can use that password reset to log into the legitimate site. The user is none the wiser, right? So this is attacking the password reset mechanism. All right, so other things that we can do is we can do session ID protection. We already talked about this before, so I won't spend too much time on that. But in this case, we're using a predictable session cookie, or we can brute force and guess over, try to generate tests of valid session ID values until we find the right one. Once we find it, then we can take over that session. Other things we can do is cookie poisoning. Mentioned that earlier. We're going into Burp Suite. This is actually OWASP Zap. We're going into OWASP Zap. talks about Burp Suite over there. But either way, we're capturing that cookie, changing the cookie, and using the cookie. Up here, I have an example of SAML. Let's talk about SAML. All right, so SAML, all right, let's talk about bypassing authentication by means of SAML-based SSO. In order to do that, we need to talk a little bit about what each of these technologies are and how they work. So first of all, SSO, what is that? That's single sign-on. A single sign-on is a way to make it so that I don't have to keep on using my username and password on multiple resources. So for instance, if I'm on a LAN or a local area network and it does not use Active Directory, and I have 3 file servers and 2 different printers, I will need a total of 6 logons, 1 for each file server, 1 for each printer, and also 1 for my local workstation. And so it gets really cumbersome. So that's why we have Active Directory. And so you log on once and you have access to your app servers, your file services, your printers, and everything with a single sign-on. And then we have SAML. SAML is the security assertion markup language. SAML has been around for quite a while, and I think the place where I use SAML the most over time has been ADFS, or Active Directory Federated Services. But there are other services. For those of you who do dev work, might be familiar with Shibboleth and with Okta and with OneLogin and others. So there are a lot of services out there. Even Google Workspaces even uses SAML. If you've ever used one account, like let's say a Facebook account or a Gmail account, to log into another service, you're making use of some type of service federation or federated services, and it might use SAML, but it might not. So let's talk about how SAML works. SAML uses what are called SAML assertions and SAML tokens. And so let's say that I have an extranet for a vendor that keeps something in stock for me. And all that extranet does is provide them with stock information. But I don't want them to have an account on my system. So I set up service federation, and I put only the service they need. And then I ingest a SAML token that has maybe the company and the user or something like that. So they can easily, with their own login back at their company, get access to resources that can help them see if my organization needs to have more of whatever it is they're selling, which might be helpful for both of us. So that SAML assertion, we can steal it, we can craft it, we can do stuff with it. So first of all, let's go over here on the screen and have a look at what we're doing with that SAML token. If you look down here, we've captured the SAML with Burp Suite. If you look over here, you'll see that sometimes SAML is not encoded very well. Base64 is not encryption, it's just encoding, and it's very easy to decode. You can use SAML Raider and tools like Burp Suite and decode SAML. Well, let's have a look at a SAML assertion. I have this is super simple. Normally an assertion is going to be about 10 times this long, but I wanted to make something that was very small. So you have the issuer, you have the subject, and then you have the assertion. And so this is going to be information about the user that's making use of SAML. All right, so when you do this, what you end up doing is taking this SAML assertion that you saw on that board, and then we encode it, and then somebody can use another tool to decode that SAML assertion. So once I decode that SAML assertion, it's almost like cookie poisoning. I can almost do whatever I want with it and then bypass authentication, gain access to resources on another system. Okay, the next thing we look at then is bypassing authentication by doing a bypass of rate limit. And so rate limiting is actually important for security for web applications. And what it does is it prevents attacks on systems by limiting the number of attempts to log in. That's very nice for that web app, because otherwise I'm going to slam over and over again with a dictionary of passwords. So what we want to do is explore the parameters, find out what's being used. You can try, for instance, API v3 sign up or something like that. There are various different ways of trying to get past it using a brute force methodology. You can include blank characters or code parameters as you see here to see if you can bypass. You can alter the IP origin using headers. Those headers would be the X originated IP and the X forwarded for and the X remote IP and the X remote ADR and the X client IP. These are just header components that you can use. And so we can try different addresses. So what we're trying to do in this case is just bypass that rate limit. The next thing you could do is bypass MFA, multi-factor authentication, 2FA, two-factor authentication. And what we're going to want to do is look at the response for a request and see if it contains success false. And then what we can do is using Burp Suite or something like that, modify it to true, set it back, and boom, you're in. Right? You have another try. And that's what we did over here, manipulated it and changed the success response to true. There are other authorization schemes that we can attack. URI, post data, query string, cookies, parameter tampering, HTTP headers, hidden tags. Well, let's look at some of those. The first one we are going to do is we are going to tamper. Tampering is so important. And I want to kind of go back and talk about something I mentioned earlier in the class. And that is a lot of attacks take an extremely long, patient, focused, iterative approach where you try over and over again using different techniques until you find your way in. So when we're looking at tampering, that's exactly what you're doing. In this case, we're doing query string tampering. And we're looking to try to get around that authorization mechanism. And so what we're doing here in this case is we have a couple of different apps going on different pages, mail, book, and login. And we are changing things around, see if we can get around it. So for instance, let's look at the middle one here. This one I've demonstrated live in my classes before. And what you do is you find, what I did in my class, is I'd find a web service that had PDFs that were enumerated with numbers. And let's say I had to purchase a PDF, and I pay $1.99 for a little PDF. And this is the number of that PDF. So what I do now is I can bypass the entire authentication process by just changing that from 69 at the end to 70. And all of a sudden, I have a PDF that I normally would have to pay $1.99 for, and I don't have to pay it. Or maybe admin is set to false because I'm not an administrator. Well, let's change that to true and then send that in, and I am an administrator, so I didn't have to do anything with that. Or we can use web spidering tools to find these. We can use the refer header to make access control decisions, bypassing some of the tools here. So in this case, what we're doing here is we're taking item 201, and what happens is the admin parameter is set to false. But again, just like this, we're setting the admin parameter to true, and all of a sudden we have access to other items, and we bypass authentication. We can also snarf, download, have a look at those cookies with Burp Suite, change the parameters in the cookies, send those cookies back in, and get around authorization that way. We can also attack the access controls. So what we do is we go through the website, find what the access controls are, what technology they're using, what levels of access can be granted, and then we can attack. We can attack user accounts, multi-stage attacks. Those sometimes are more effective, and many other methods that we can use. We can do parameters. We already talked about refer headers. Location-based is probably, of all of these, the easiest to do, because if there is something that you cannot do because you're in the wrong country, you just change your country, right, using a proxy or a VPN. Next thing we look at is the session management mechanism, and we have session token generation and session token handling. We already talked about this in previous versions, not versions, but previous modules of the class. And so we're not going to spend time on that. But then we can also do token sniffing with Burp Suite. We can capture information from unencrypted tokens using Wireshark and examine that session information and maybe use that to get around the authentication or authorization by finding that session information. We can also manipulate WebSocket traffic. So we actually see a multi-step methodology for doing that. So what we're going to do is we're going to use Burp Suite. Yeah, this is Burp Suite over here. By the way, they show you some of the locations where the tools that we use for the CEH, where we get them. Burp Suite is at portswigger.net. But either way, what we're going to do is manipulate WebSocket traffic. We're going to modify it. We're going to relay it. So how do we do that? We start with, hey, open Burp Suite. Yeah, that's good. Okay, I can do that. And then just like we're going to do in the lab, you enable interception, browse to the application. We're going to go to proxy WebSockets history, right click on the entry. We're going to have to send to repeater. That's going to be very important. And then we go to repeater. There's a little pencil icon next to the WebSocket URL. And then you're going to select the socket, clone it, and then run the connection. And then hit that pencil icon again to see if the new WebSocket connection was successful. And then we hit send to transmit the WebSocket over. So this is similar to some of the stuff we're going to see in the lab. We're going to do it step by step. One of the things that you'll see with Burp Suite is you also need to modify your browser to use it. We'll do that in the lab. They left that step out in here. But either way, yeah, we can use that to analyze and then manipulate WebSocket traffic. The next thing we look at is injection and input validation attacks. This is extremely good when we're doing SQLI down here. But command, web scripts, SMTP, you can do it for spamming. We already talked about LDAP. You can use XPath injection with malicious strings for XPath queries. We can manage buffer overflows. We already showed a couple of examples of file injection. So there's a whole package of injection attacks. And one of the attacks that's really nice to use is LFI. Let's have a look at LFI. And what LFI is, local file inclusion. So what we're doing with local file inclusion, it's an exploit that allows us to take advantage of the local system on which the web app resides. And so what we're going to do with that is we're going to exploit some vulnerabilities. We're going to, like, for instance, evade the added PHP or other extensions. And so what happens with web applications, they'll use dynamic inclusion files. And what they do is they append an extension like PHP to the input that's provided by the user. So if the file name is not validated, well, then we can do that ourselves, and it can be exploited. So if you look at the code example here, we have $file, and we have a $get page require file PHP. So in this example, the application is going to take a page parameter for the URL, append a PHP to it, and then includes it in the page using the function that it needs. And so the exploitation techniques that we can use, number one is the null byte. The null byte is very good for bypassing that PHP extension by adding a %00, which is going to, if we're dealing with C-based languages, it's going to say, hey, that's the end of the string. And so we trick the web server into treating the file as if the PHP extension was never appended. So an example, if you look over here, this is the XYZ page where we do that /////. We're moving through directories there, out to the Etsy directory. And then we do Etsy password, right? That's some good juicy information. And then we do a %0. Nice. So now it's going to say, well, that is no longer happening. And so it's going to not take the rest of what's supposed to be appended to that string. And then over here we have the question mark exploit. And so this is just another bypass of that PHP extension by appending a question mark at the end of the file path. And again, what we're doing is tricking the application to ignoring the .php extension. And so in both of these examples, what we're trying to do is access the Etsy password file that has information about the accounts on the server. And over here on the right side, that's what we're doing with the LFI. We're bypassing that PHP. You can use like base64 encoding to bypass it using PHP filters to read the source code of the PHP files without executing them. And we can convert that convert.base64 encode. We can convert the file to base64 from base64. But either way, if you look at this example right here, xyz.com/index PHP, and then we have the page equal PHP, filter, convert. There's that conversion I was talking about before. So we have an index PHP file that's being targeted. The PHP filter is used to encode the file content in base64, so the attacker can then decode the base64 output and then read the original source of that file. So that's LFI, local file inclusion. A little bit later, we'll talk a little bit about remote file inclusion. These are some basic examples. There are so many other things that you can do with LFI. Next thing you want to look at is an application flaw. There's a problem with our developer. All right, he wrote a nice program. It's an entire retail web app. It's wonderful. It works great. People are buying stuff. But he made a fatal flaw, and that flaw is to assume. And what happens when you assume? You make a hacker victim out of you and me. So here's the assumption. Look at this. We select a product, we finalize the order, we proceed to pay, and we deliver the details. Wait a minute. What's the assumption? The assumption is that everybody is going to follow that path. But see this guy over here? Well, he just decided to get stuff from the site without following that path. So what he did is he skipped proceed to pay. So how could we have avoided this? The way we could avoid this is we can have the delivery details module back reference to the proceed to pay. So you have to have proceeded to pay before you do that. You have to have finalized order before you do this. So we have chains of logic that are enforced rather than assumed. Also, shared environments. We'll see this more in the cloud section. You may have a cloud or another type of shared environment, and you might be able to attack the administrative web interface. You might be able to cause one application to leak into the other. You might be able to look for configuration errors and hack through that. You might be able to do SQLIs and other types of injections on the interfaces in shared environments. You can also attack database connectivity. So let's talk about that a little bit. So for database connectivity, you have an app up here on the top, right? So you have this application, and then the application has multiple layers, which I'm not going to talk about, but underneath that app exists a database. And in between the two of them is a layer that tells that app how to connect to and make use of that database. So how do we connect to it? Well, we use this connection string, and it gives us information. So what I can do is use multiple techniques to attack that connection string. Let's have a look at it. And we see there are three major types. One, there is connection string injection. The next one is parameter pollution, or CSPP. And the other one is connection pool DOS. Let's have a look at one at a time. Before and after. So before injection, look at the string. It tells you how to do it. The source, the port, gives you the library you can use. It gives you the initial database and, oh, hey, a username and a password. After injection, the problem is I wasn't able to read any of that stuff. But now I turned encryption off. Dun, 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 the plot thickens. So now it's not encrypted, so I can sniff what's going on there. And the next one we have is connection string parameter pollution attack. So the first one we have, well, we have that connection string first, right? And the connection string has a lot of parameters in it, right? Having things like we saw before, database name, the server name, credentials. We saw that an admin equal true, or we could set security settings. So one of the things we can do is try to overwrite those parameter values. We can do hash stealing. So we want to steal Windows password hashes. What are we going to do? We're going to trick the application into connecting to a rogue SQL server. How does that work? Well, what we're going to do is we're going to replace the data source parameter right over here where it says my server. So we're going to replace the data source parameter in the connection string with the address of the rogue server. And then we have this bash code copy that we're doing. We have the source, my server, initial catalog, etc. So now when the application tries to connect using Windows credential, the rogue server can capture the password, hashes, and credentials. Hey, that's pretty smart. Another thing we could do is port scanning. And so what we're going to do with port scanning is we're going to scan different ports on the target server. Isn't that cool? We'll see that again in SQLi in the next module. But what we're going to do is we're going to modify that connection string and determine what ports are there, open or closed, etc., based upon error messages that are received. So what we do is we go over here, we see this where we're going to modify the port parameter. And so we analyze the server's responses, and we can identify open ports and potential points of entry. And then lastly, hijacking web credentials. So what we want to get is unauthorized access by using system level credentials instead of those pesky user provided credentials. And so what we're going to do is modify the connection string to use an account that might have higher privileges. Right? So once you do that, you can gain access through those privileges. So like a DBA or a DBO or something like that. So lots of different ways of using those parameters, modifying them to gain access to information that otherwise should not be available. All right, so another thing you can do for the connection pool is DOS it. DOS it. So if we look at the DOS that we're doing here, in ASP.NET, you're allowed a maximum of 100 connections in 30-second timeout, right? So that's the max. So what we do is we send in information, and there's a 30-second timeout too. So what we want to do is exceed those parameters, and eventually it blocks that connection pool, and it allows that app no access to that database. Another thing we can do is we can attack the web application client. So we have server-side applications, but they're going to run on a client. And what we're going to do is we're going to try to get to data on that web server from the client side. So we have a nice surface area that we can deal with for attacking. We have everything from SOAP and XML injection that we can do at the client, web services client. We have a WSDL probing attacks that we can do in between the client and the backend. And here in the backend and towards the backend, the logic in the backend, we can do information leakage, application logic. We can reveal that. We can do database attacks and DOS attacks. So, and these are just an extremely small overview of what you can do at every area of web services. So what we want to do with the web services is start with a probing attack, send in a SOAP request and see what we get back. And if we get an error, sometimes the error is a TMI error. It leaks too much information, and we can use that to characterize the web services. We can do SOAP injection. And so in this case, what we're doing, this is actually SQLi, but because of the backend methodology that's used to transfer that information through the app, it's characterized as a SOAP injection attack. And sure enough, we get a nice response. The response gives us information about the SOAP envelope, information about the app, etc. So again, I can use that to further characterize the application architecture. You don't have to come up with your own tools, because we have stuff like WS Attacker that you can use to help you characterize the architecture of the app, doing XML parsing and looking at the SOAP architecture. You can use WS Attacker for that. We also might want to do WS address spoofing. And so WS addresses, what are they? Well, they give routing information. For the SOAP header, the purpose of the WS address is to help with asynchronous communication, so you have better flow in an application. So what the attacker is going to do is use a fake WS address. It's going to get that into the server, and from there, the attacker is going to be able to grab more information about the server, and in some cases, insert information into that app. And then we can do XML injection. So in this case, what I do is I just drop that into this email section of the app, hit submit, and on the server side, what we see here is it created a new user account. So I have the user account, the password, it's all characterized, and then I can log in on there. So bogus XML entries injected into the web app. We can also look at that web service and parse it. But in this case, the parsing is meant to break it, or at the very least, cause errors to happen that I can analyze to further characterize the web services. So one is by using recursive payloads. So how many times do we need to go through processing? Well, just infinite. Yeah, that's what we want. So infinite processing loops that exhaust the XML parser, they blow up that CPU, and eventually you'll get errors or you'll DOS it. Oversized payloads. So you use a huge, ginormous payload. Again, what's it meant to do is to exhaust system resources. And so again, the web resources will be inaccessible. There are tools that can help you with both of those two attacks, and many of the ones we've been talking about in this section. One of them is called SOAP UI. It's a little web service testing tool. It's great because it uses many protocols like SOAP and REST and HTTP and JMF and AMF and JBDC and many others. And so you can go through and run SOAP UI, and it gives you the layout. XML Spy is a very good one. It's a little editor and dev environment. You model, transform, debug XML related technologies. But if you don't want to use these tools, just ask your local LLM. That's right, we can create custom scripts to automate our web applications using artificial intelligence. And so here what we're going to do is we're going to say create. So that's a good one. We're going to put something together, right? We're going to do a little coding and run a custom script for web application footprinting. That's number one. And vulnerability scanning. That's number two. So whenever you're setting up a LLM to do some work for you and you're putting together the prompt, keep in mind all of the parameters that you want it to do. And if it's more than one or two, this is just two, right? Footprinting and vulnerability scanning. If it's more than two, then sometimes you'll need to explicitly state, make sure the following 5 conditions are met or something like that. That'll help with the tool. So the target URL is www.certifiedhacker.com. So we send that in, and it creates the script, a little bash script here, and then it does the scan for you, pulling the requisite information. Over here, we're going to create and run a Python script for web application footprinting and vulnerability scanning. The target URL is certifiedhacker.com. It creates a script and runs it. And in this case, you see that it's finding information on the web application firewall and doing a variety of, using a variety of tools to make it happen. So that's actually pretty cool too. But if we go over here with the same script, we are going to use. If you look at this is a very interesting command that it created to allow you to run it. And it is a long name for this script. But either way, what happens at the end is it gathers information on it, prints it out for you, and it's just so cool that you can use an LLM to run all this stuff for you. When we get into the lab, we'll also be using tools like this and others to be able to characterize and attack web applications and web services. We're now in learning objective number 4. We're going to look at web API and webhooks. Okay, so what is web API? What are webhooks? So let's have a look over here. And an API is an application programming interface. It's a way that one application can have access to services from another application. It's almost like a back channel. And so it gives that a back-end resource for exchanging information, updating multiple online sources. APIs are actually very cool. And when we look at web APIs, we're looking at things like SOAP API, REST API, RESTful API, XML RPC, JSON RPC, stuff like that. And it allows all those services to be made available. So these are very important, and they are hackable and attackable. The next thing we look at then on the right side of this slide are webhooks. Okay, so how can you tell an American on vacation in the beach? Well, she's working on her laptop. Yes. On vacation, working on her laptop. Yeah, that's what we do. But she's working on the laptop, and she has a window open, and she is about to purchase some more, I was going to say Bitcoin, but let's go for Dogecoin. She wants to purchase some more Dogecoin. And as she's looking at it, right before she hits buy, the screen updates, and now Dogecoin costs a lot more. It's like, I just missed it. I can't believe it. What happened? How did that screen update? So it could be on social media. It could be on any type of web app where the screen automatically updates. One way to do that push notification is through webhooks. So we have events that drive it, send that post request out to the app. The app is updated. And so those are event-driven HTTP callback push APIs that will do that for you. It's called a webhook. All right, so we have APIs all over the place in our web applications. And oh, wow, there are a lot of things that can cause that web API to be vulnerable. So broken object level authorization, authentication, and so on. These are the OWASP top 10. And I'm not going to go into each of these. There aren't any weird terms or anything in these. This is something to keep in mind. It's unlikely that someone will say, what does API 4 in OWASP top 10 say? I mean, so, everything is fair game on the exam, but we don't go deep into each one of these. Security risk for webhooks, because remember, a webhook is going to be a triggered transaction. And so you might have data that's exposed. It could be replayed. It could be unencrypted. There can be duplication, forgeries. So there are various dangers with webhooks. And then APIs themselves have vulnerabilities. And again, most of this stuff in here is something that you would know, but let's talk about a couple of these, because maybe there are a couple acronyms that you may not be familiar with. So let's have a look at those. The first one that I want to focus on is this one. Again, we're in vulnerabilities for APIs. And it says improper use of CORS. When you see CORS, you're like, isn't that a bear? No, that's not what I'm talking about here. I'm talking about cross-origin resource sharing. And this comes up in a lot of application security, so it's a good thing to look at it. So it's actually an HTTP header, a header-based mechanism that's going to allow the server to indicate any origins. What origins? Like, for instance, domain or a scheme or port origin. You can do all of those. And so what we do is we look for origins other than the ones that the browser should be permitted to use. And so it's a mechanism that it relies on browsers to make what's called a pre-flight request to the server that hosts the cross-origin resource. So, and all that said, now we look at what it says here. It says CORS is a mechanism that enables a web browser to perform cross-domain requests, and improper implementation of CORS can cause problems, right? So, because otherwise you can allow the attacker to go outside that domain also. And then another one here, number 7, ABAC. ABAC stands for Attribute-Based Access Control. So if you look at this one, it says lack of proper ABAC validation allows an attacker to gain unauthorized access to API objects. So what is it that ABAC does? What happens is you have many different types of access control, but ABAC, attribute-based access control, can allow you to be more fine-grained. So you can really fine-tune the access for that resource. So those are just a couple of acronyms that I thought maybe some people aren't familiar with. So let's go on to the next one. I want to hack an API. What do I need to do? Well, we need to find the target first, detect the standards, identify the attack surface. We're going to characterize that surface of attack, and then, and only then, can we launch our attack. So the first thing we need to do is identify the target. So we have APIs. We're focused on APIs here. SOAP, REST. Mostly we're going to be using HTTP. And so what we can do is we can send in a message because of the plain text possibilities that we see here. And so we can send in a message to get a response. So we send in a request. We have a request line. We have the request headers, the message header, and then we have a blank line and then the body of the request. And then we get a response back. And the response that we get back, what are we doing here? Helping us identify the target. So we get information about the target. It's an Apache 2.0. We get information about how it communicates and so on, versions, etc. Next thing we do is we detect the security standards. Is it using OpenID? Is it using SAML? Is it using OAuth, WS security? And so what we want to do is look at that transport level security, see if we have encryption running, see if it's configured appropriately. One tool that's very good for this is API enumeration. It's a little scanning tool to help you find information about those APIs. There are many different commands that you can use, like for instance, KR scan, and then you give it a single target, or you have a single target, but you're looking at both HTTP and HTTPS, or you're running an entire list of targets. So it's a very nice tool to help you find that information. We want to identify the attack surface, looking at metadata, seeing if there are vulnerabilities in the metadata, looking at paths, parameters. We're looking at message formats. And what we're doing is we're discovering the API. And not only are we discovering the API, but we're characterizing it. So let's have a look at a tool that we can use to do that. And that is the Swagger definition. So for those of you who are into dev work programming, you're familiar with the Swagger definition. It's a widely used framework for API documentation. You use it for API design. And what you do is you design and characterize the structure of your API. You get the endpoints, you get the methods, you get the request parameters, you get the responses. And Swagger is standardized. So you get a standardized format. I would say that it's usually the most popular when dealing with RESTful APIs because you get a nice, clear, machine-readable description of how the API works. So the Swagger definition, this is the core file. Often you'll find the definition written in JSON or in YAML. It's going to describe the entire API. This is a portion of it here. Details about API paths, details about operations that can be performed like get, post, and delete. The paths, you get the endpoints, endpoint path. For example, cust ID endpoint. We get operational methods that you can run, like the HTTP methods. Over here we see delete. You can do get, you can do post, and other methods. And you also have the security that it's used, like OAuth 2 or something like that. And you get the metadata that's included with it. So the Swagger definition is very useful in the characterization of the API surface area. However, there are tools that we can use for that purpose. This is actually a really good one that you can get from Postman.com. Postman, you can capture the API traffic. You can look at requests and responses. You can look at cookies, and it's a built-in proxy that you use in Postman. So now we launch the attack. We finally got to where we can launch the attack against APIs, starting with fuzzing. So we already looked at fuzzing in depth when we were in module number 6. We're throwing all kinds of data at it, looking at attacks that are invalid inputs. We'll see this, especially in SQLi. What we're trying to do is manipulate the app to give us errors that we can use against the app to find information. We can do stuff like XML bombs. These are malicious input. We set up something like you see on the right here, and you upload that script instead of a PDF document, for instance. And then you set that bomb off, and you can cause behaviors in the app that can be used sometimes to DOS the app, but other times to characterize it and get information about the API. In this case, we also are trying injection attacks to see if the API is vulnerable to injection. So we have a URL here, and what we're going to do instead is we're going to do an SQLi. Right over here, we do another SQLi. We're going to see more about how that works when we get into SQLi, the next module. But there are a lot of injection attacks that you can run. You can look for insecure configurations. If you can find an insecure SSL configuration, then you might be able to do a man-in-the-middle attack, maybe manipulate the client certificate. We have IDOR, we have insecure session authentication handling. So quite a few things we can do against that API. So let's focus in a little bit more on what some of these things are. So one I really want to spend a little bit of time talking about is IDOR. All right, so IDOR is a type of access control vulnerability that's going to happen when an application, essentially it exposes references to internal objects that it shouldn't, right? So these are going to be things like records, databases, files, and other types of information. Oh, even user account information can be exposed. So what we have then is the attacker can manipulate those references in order to gain, again, unauthorized access to the data. So the way it works, we have an IDOR object reference. So that's a direct object reference. So applications might use things like a user ID or file name or database key or something like that in the URL, or maybe they'll request parameters to reference an object. So for instance, URL might use a parameter like ID123 to refer to a specific user account. So here we are. I put together a little code snippet, and there it is, ID123. So we're referring to a specific user account. So if the application doesn't validate that the user is actually making the request has access to a specific object, what happens is, as the attacker, we can modify the user value and get access to that data. So it's possible to do this because the application directly exposes the identifier and then relies on the client to provide it. So let's have a look at this. So this one is a little snippet of code for IDOR. So yeah, let's say you have an online banking application that allows users to view their transaction history by visiting a URL. So this is one Bank Corp transaction account ID 12345. So in this case, with that account ID 12345, again, that's a direct object reference. So that's the user's bank account. And it's going to fetch and display that transaction information. And that's vulnerable code. So what we do is we download the code. And then if we download the code, then we can run an IDOR against it, give it a different account ID or something like that, and successfully look at, view, manipulate another user's account information. So, so I just wanted to kind of zoom in on that and talk about that a little bit, but that's IDOR. Another one that we have is credential stuffing attacks. So what we're not doing with credential stuffing is we are not using a whole bunch of random passwords from a dictionary. So what we're doing then is we are using passwords that we have early identified. These are paired credentials that have been identified earlier. And we can automate it with tools like Sentry MBA and Phantom.js. And what we're doing with those paired credentials is we're going to be breaking into accounts. That's credential stuffing. And then API DDoS. You can take down the whole API. And so let's look at the steps in here. So first of all, we're going to set a bot command and control handler. So let's do that first. Now, by the way, each one of these involves a whole lot of other sub-steps, but we're going to infect a machine. So now this machine is a bot, and now this bot looks for other vulnerable systems to infect them. And now we have an entire botnet. And now those bots say, hey, I want you to know I have infected this computer. It's a shambling zombie now, and we're ready for your instructions. And so now this dude right here with the red skull, the attacker sends commands to the bots through that command and control service. And now we target not the website, not other components, but specifically targeting the API, saturating with a huge volume of traffic and causing it to break down. So that is a API DDoS attack. But we also can do attacks against OAuth. OAuth is one of the most used web application authorization, authentication schemes that we can use. And it helps to limit the access of users. And OAuth, I mean, if you look at it from the programmatic point of view, there are a lot of different ways that you use it. There's a connect request that can be attacked to gain illegal access. There's a redirect URI that can be attacked to get onto and through that web service. There's CSRF attacks, or you can reuse access tokens. So quite a lot can happen with OAuth, including SSRF and WebFinger and flawed scope validation. And I guess it would be worth it to take some time and look through each one of these. But overall, know that there are a variety of attacks that you can run against OAuth also. Other techniques to have an API. Reverse engineer it. Have a look at it, characterize it, look at it at the code level, find out how it works and reverse engineer it, and then that'll help you find ways into it. Spoof users. We already talked about MITMs, especially where we have unencrypted content and communication. We have session replay, talked about that before. And if you're still having trouble hacking the API, just ask someone. Yeah, social engineering. And there are tools to help you with attacking the API. Fuzzappy. So Fuzzappy, that's a fuzzer, right? We've seen some other fuzzers before. And then we have a WAF, and we have WebSpider and Vuki, and OAuth Zap comes back. But the one that all of those that we're just talking about, they're not specific to APIs. But Astra is specific for APIs, and in particular, it detects REST APIs that are vulnerable to attacks, and it'll list out the types of attacks. You can do cross-site scripting, SQLi, leakage, CSRF, and stuff like that. Okay, so another thing that we want to be able to do is bypass. Remember, we just spent some time talking about insecure direct object references. That's that vulnerability we were talking about just a little while ago, where they just disclose those direct object references in the data. And so again, we're just doing that here. We're just changing an ID. This is very similar to what we saw before. But down here, we're showing the methodology that you're going to use. Yeah, you could do it on the URL, but usually that is going to be encoded or hidden. So you can come back down to Burp Suite and do parameter pollution from Burp Suite. Okay, so we've talked quite a lot about attacking the API, so many different ways. But what if you wanted to defend your API, have threat detection, have confidentiality, have integrity, you have audit management, authorization, and API security admin? What would you do to have all that happen? By the way, that's what it all says right down here. You use an API gateway. As you notice, down here, the enterprise network, before you can go to any services that are internal API servers, guess what you have? That API gateway. Before any mobile device or cloud or other client needs to get to these API servers, guess what they need to go through to secure your API architecture? The API gateway. So remember, that is one of the quintessential ways to defend your API architecture. So for APIs, there are many insecurities, I guess you could say, security risks that we want to talk about. And those are going to be broken authentication, broken object property level authorization, and many others. So like for most of these, I'm not going to go through each one of these because we're going to go through page after page after page after page of these. And we could literally take the same amount of time that the module takes just to go through some of the remediations. But I will point this out, and one reason why I talked about this earlier is because it fits into a lot of mitigation strategies, including security misconfiguration. Again, here we have implementation of a proper CORS policy. All right, best practices. Again, these are going to be items that you need to discuss with your dev team, sanitizing the data, making sure that you have good signatures and trusted identities and API gateways, and you implement MFA and so on. For webhooks, again, dev team stuff. So if you're on operations, you're not going to do webhook signing. That needs to happen with your dev team. You're not going to reject webhook calls from unauthorized sources. Why? Because if you're in operations, you're implementing the application. But for those of you who are on a dev team, these are going to be the things that you're looking for, validating the XOP timestamp, things like that. So I'm not going to get into the deep weeds of all this, because then we have to talk about where everything comes from. And if you're dealing with a dev team, they will know. Or if you're a developer, you will know. We're now in number 5, and we're going to summarize some of the techniques that are used in web application security. So in this module, we have been talking about hacking web applications. And in this section, we're moving from attack to security. And the vast majority of the security we're talking about is kind of coding stuff. So in order not to explain every code and come up with code examples and so on, there will be a lot of stuff that we will overview, things you're going to want to discuss with your dev team, your SecOps team, things like that. All right, so other items are stuff that a pen tester or an ethical hacker will directly deal with, and we'll focus on those. The first one we have is security testing. And this is definitely something that a pen tester, ethical hacker will deal with in defending the application. So what we can do is manually test the application. We can use tools to automatically test the application. So like Ranorex Studio or Test Complete and others to run that automated testing. We can use SAST and DAST, statically testing and dynamically testing, kind of like what we're talking about in Module 6 in the malware module. One of the big ones that is used to test an app, just like we saw in the malware module, actually it was in the hacking module number 6, is fuzzing. So we send a huge amount of data to the app to characterize how it fails. We can also do fuzzing with AI. And in this case, we're using SGPT and we're telling it to fuzz the target, right? So fuzz the target URL and give it the URL, and then say using the WFuzz tool. We can use AI-powered fuzz testing with utilities like Prompt Fuzzer. It's in Gen AI, and you could do real-world attacks, analyzing from the back-end large language model. It's an example of it running right here. We can do AI-based static testing. So in this case, we have Code Genie AI. We have Cogdia and many others like CodeThreat and so on that we can use, AI-based at the back end. We can do AI-powered dynamic security testing with things like ZeroThreat.ai, and it's AI-driven. It's an intelligent crawler, very good at eliminating false positives. There's also VoltSec.io and AppCheck and others that we can use. A lot of these AI-driven. Before we do any of that testing, the first thing you want to do is source code review. And what I like to tell my dev teams, jokingly, of course, is you don't have to worry about source code review, because if you don't do it, don't worry, the attackers will do it for you, right? So what we do is we want to avoid poor coding techniques. And so we push the code, review the code, modify the code. If it's okay, we build and deploy. We have automated ways of doing that. We have manual where we develop, review, and feedback. And either way, that code, CI/CD, pathway, should be twinned with a good DevSec methodology to make sure that every line of code and every app is as secure as possible. Also, we want to use encoding schemes. Let's have a look at some of these encoding schemes that we see here. We have URL encoding. I'm going to go to the next slide and then come back here. So we have base64 encoding and even hex encoding. So let's look and talk about why it works. So if you look here, here we have URL encoding. What we're doing with this is we use it for a web application to make sure we're safely handling it and transmitting data that includes special characters like select star from or whatever, or maybe binary data. We want to ensure that the data is interpreted correctly. And so what we want to do is represent those unusual characters appropriately. So if you have a URL, you have an HTML document, for example, the ampersand character in HTML is used to say that this is the beginning of an entity. For instance, ampersand amp, or the slash character, which is going to say this is a directory. So if these characters are sent in their raw form, they might be misinterpreted by the system as some type of control character. And that's exactly what we're trying to do as hackers, is use control characters to take over, but we don't want the app to do that. So what we're going to do is encode these characters so that they don't get passed to the underlying app. So we have a URL, HTML, and others that we were just talking about. All right, so whitelisting and blacklisting. Application whitelisting says only these things are allowed to be on this web server or whatever it is we're looking at. So software libraries, plugins, extensions, configuration files, only those. If anything else shows up, like if someone asks me to pen test a web app and I CNC some type of stuff there, or bring it in through another means, it will be caught. All right, what about blacklisting? These are the things that we don't want on this web app, right? It's threat-centric, and this is what you want to, so that is threat-centric. We're looking at applications that are a threat, components that are a threat. But this is trust-centric. So we're looking at things that we trust, and we're allowing those to go through. So know the terminology, the differences between trust-centric. I trust those software libraries. I trust those plugins. Threat-centric. We don't trust that software, those libraries, those locations. So that's the difference between the two of those. Next thing we look at is some tools that can help out. ManageEngine, Bitdefender, Cisco Umbrella. There's a small company you may not have ever, a tool, Symantec. Have you heard of Symantec before? Everybody knows Symantec. And so we have all these different tools that we can use to whitelist and blacklist. And then we want to filter content. So this is one called Titan HQ. That sounds pretty remarkable. So it blocks phishing attempts and other types of attacks, and NG Firewall Complete and Smoothwall, FortiGuard, Barracuda. All these are really cool tools. We also want to defend against injection attacks, and this is where we get into some of the stuff that we want to talk with our dev and DevSecOps teams about, because it gets pretty low level. I'll highlight a couple of these. So for SQLI, again, we're going to get into that next module, but there are commands like XP_CMD shell that will actually interact with the underlying operating system. We want to disable that. Then we have ways of protecting LDAP, mainly encryption. We look at command injection flaws, and we want to be very careful to validate input, use safe APIs. File injection attacks, we want to create a chroot jail. This is something you can do to make sure that only certain capabilities are allowed. Next thing we look at is server-side injection. Again, we look at functions that we want to avoid using, like the eval function. We look at server-side, where we're looking at dynamic data if it's passed to a template using the engine's built-in functionality. I mean, yeah, are you gonna do that in ops? You're not gonna do that in ops. That's gonna be your dev team. And so each one of these, for server-side and for log and for HTML, CRLF and cross-site scripting, these are things you're gonna discuss with your team. So for instance, for HTML, we want to do input validation. And then for CRLF, we really want to stop these characters from going through. And you know what? Let me just spend a couple of moments and talk to you about where CRLF came from and why it works. It's really interesting because this is I guess you would call it an ancient technology. So no, it didn't come from the time when we would chisel ones and zeros into rocks, but just about. A long time ago, let's say that it's 1960, and you are in high school, and you need to type a paper. What are you going to do? Yeah, you might write it out, but if you need to, you're going to use a typewriter. And a lot of you that are in this class have never used a typewriter, so you don't understand how they work. So every time you hit a key, it goes, and the little hammer hits an ink ribbon, and it impresses the letter or the number on the page. And then when you get to the end of the line, the first line you're typing, guess what happens? If you keep typing, it'll go off the paper and it'll start typing on the rubber roller. So guess what you have to do? There is a handle that you grab, and the rubber roller and everything that's being typed up on is called a carriage. And when you hit that handle and you drag it back, it returns the carriage to the start. And there's a little gear mechanism so that when you grab that handle, it does a line feed. Carriage return, line feed. Okay, so enter innovative organizations. And the innovative organization that I want to introduce to you is one called IBM. So IBM entered the scene and they created a new electronic typewriter, and it did the carriage return inline feed for you. It had a little ball that had the raised characters on it. It still stamped it into ink, but now it was for you. And so on the keyboard of the IBM Selectric typewriter was a return key, which still exists on many keyboards to this day. And it doesn't return a carriage. It says enter, which is what we have on most keys. And from that Selectric, then we got into things like the IBM 360 and the PDP-11 and the DEC 10 and these mini computers and mainframes. And then pretty soon we went into PCs, and then we went into local area networks, and then clusters. And we still have CRLF. Isn't that interesting? How something from way back when still survives and is able to be used to hack a computer system. So what we want to do is encode that with special characters so that it doesn't tell the underlying system to stop. And then the hacker code will run after that. And then for these, we want to validate headers, validate cookies. We want to extensively test. We want to defend against broken access control by making sure that we do access control checks and making sure that we are aware of how we secure our app through the secure development lifecycle. We want to make sure that we are not using weak cryptographic algorithms. Oh, unless you do want someone to hack your web app. So maybe like AES 256, that's nice. RSA 2048. And something I'm going to talk about on the last module that I would like you to consider right now is that some of these algorithms, security algorithms, are obsolete. Why are they obsolete? It's not right now in the present, it's in the near future because of quantum computers, specifically RSA. And so there are security algorithms that have already been developed by organizations, and NSA had a contest, and there are some winners. And you can begin to implement quantum safe algorithms already if your organization wants to. And then we have security misconfiguration. So you want to make sure you don't have defaults and default contents and default accounts. You want to make sure you parse your XML so you don't have external entities. Make sure you look for every component that's in your web app that is not old. Like you have a developer, it's like, I always use this component. This works great all the time, but they don't realize that that component is actually vulnerable. So you want to check every component, make sure we're testing in our apps for IAM and providing good IAM policies. We want to make sure we don't have integrity failure. Supply chain, that's a big one. Making sure that we're using appropriate digital signatures, logging everything that's happening, making sure that we are using trusted classes for our serialization and good libraries that give us secure serialization, making sure that we're not allowing directory traversal. What are we going to do? We're going to protect those areas of the website, do hot fixes and making sure that we remove or encode characters. We already talked about encoding characters. We're going to make sure that all of our redirects and forwards are validated. And in this case, and in some of the cases that we're talking about, in order for you to do the protection of the app, you may have to re-architect the app. Again, we're going to go characterize the entire application and web environment to see what watering hole attacks can occur, and then make sure that we block those sites, defend against those. We're going to use unique CSRF tokens so that we can avoid CSRF issues. We're going to use timeouts, and we're going to randomize sessions to avoid cookie session poisoning. We're going to use WSDL. We're going to configure the permissions to deny access to WSDL-based SOAP, and many other things at that level. There are things you can do to defend SAML using appropriate certificates. We're going to defend against clickjacking attacks, like making sure that you use a server-side method. This is X-Frame options header and uses options. which are deny, same origin, and allow from URI, so that you don't get somebody that can run a clickjacking attack. And make sure that we use CAPTCHA for usernames, and for JavaScript hijacking, you need to code it correctly, right? So maybe even using an encoding library. And then for password reset, you want to use proper validation of tokens. And again, CAPTCHA is very good for this also. And then we have a huge set of best practices for WebSock, including RBAC and tokens and rate limiting and sub protocols that are correct. And we have a huge number of things we can do through all of the coding techniques. And by the way, what if you're coding in C#? We have another set of techniques. What if you're coding in Python? So depending on the language that you're using, especially if that language is part of a very large architecture like .NET or Java, there are going to be manufacturer specific recommendations for code security. You need to follow those. But another thing you can do is you can use RASP. RASP is runtime application self-protection, helping you take your web server over here, going through the internet, and before anything gets to the web server, we run it through RASP, giving you visibility, giving you a better DevOps collaboration, helping you with pen testing, incident response. And so there are some security tools like NStalker, helps detect and prevent. Oh, it's not going to prevent it for you. It's going to just detect it and tell you what it is. And then you have to fix it. We have Veracode, been around for a long time, and they're still updating it. It's very good stuff. Sync, and many other tools for that. Then we have firewalls, web application firewalls, like from Cloudflare and Imperva and Qualys and Barracuda, that can defend your systems. Okay, so it's been a very short module. Got that done in just a couple of minutes. No, actually, you've seen this is a lot of stuff, isn't it? I mean, we look at everything from how web applications function, and then we break it down into components. We looked at the web server in the last module, but what's running on that web server? It's a web app, multiple web apps. And those web apps have architecture styles of various types, including APIs and so on. And so for each of these, there are methodologies for attack. And we saw that there is quite a lot to cover, and we just overviewed it for what we can do to defend everything from web APIs to web hooks to certain technologies like Java, etc. So it's very important for you to take a look at some of the areas that I focused on and I pointed out so that you can be ready for the exam. But what we want to be ready for right now is the lab. There are some really good exercises that we're going to do. And after you finish the lab, join me in the next module. In the next module, like I've been saying a few times, we're going to go over SQL or SQL injection. We'll see you there.